welcome to my channel Chemistry by PNSK. In this class, we are discussing about the Schrodinger wave equation. Schrodinger wave equation. Here, Schrodinger wave equation is the basic for the quantum mechanics. Okay. For classical mechanics, Newton's laws are the basics. For quantum mechanics, here we are taking the Schrodinger wave equation as a basic one. For quantum mechanics, we are taking the Schrodinger wave equation as the basic one. Okay, before going to teach about the Schrodinger wave equation, once we can recall our previous atomic models. Okay, what we have discussed in the previous atomic models? In the year 1913, the atomic theory of Bohr's atomic theory. Bohr's theory is telling that this is a nucleus and this is the orbit. Bohr's theory explaining that electron was revolving around the nucleus in a closed circular path. Closed circular paths. Okay. By this circular paths, he is telling that there is a finding of position of the electron and momentum of the electron easily. Position of the electron, momentum of the electron finding easily according to Niels Bohr theory. But later on, 1923, the scientist called de Broglie, he is telling that no, there is a revolution of electron around the nucleus in an atom in a wave motion. Okay, he is providing that this is the nucleus, this is the orbit. Electron revolution in the nucleus. Electron revolution in the orbit is wave motion. Okay, by this wave motion, he is providing wavelength of electron wavelength of the wave is h by mv. Okay, after to the de Broglie equation, the scientist in the year 1927, Heisenberg was evaluating this one. Heisenberg is providing the uncertainty principle. Uncertainty principle. In uncertainty principle, he is telling that there is a probability of finding the position and momentum of the electrons. Probability of finding position and momentum of the electrons. Momentum of electrons. During motion of the electron, okay, there is no possibility for finding the exact and accurate values of the electrons, but probability of the finding of position and momentum are explained, which is nothing but we can find the values with some error only. We can't find the values exactly and accurately. That's why he is telling the probability of the finding the position and momentum of the electron, and he gave the equation is delta x into delta p greater than or equal to h by 4 pi. Okay, by using this equation he is explaining about the probability of the electron for finding the momentum and position. Okay, by these two theories, a scientist called Schrodinger evaluated the equation. Okay. By using these two theories of the de Broglie wave theory and Heisenberg equation, uncertainty principle equation, Schrodinger was providing the equation for finding the quantum mechanics. Okay, let's see that one also. Okay, before going to learning about the Schrodinger equation, we have to know about two units, nothing but a wave function and probability density. What is the first one? Wave function. Wave function is nothing but the explaining about the address of the electron. Okay, address of the electron is explained by wave function. The electron is where in the orbits, it is explained by wave function. It is denoted by psi. Okay, it is denoted by psi. Next, coming to probability density. Probability density. Here address of the electron is explained by wave function. Probability density nothing but the region in the space of the electron around the nucleus is nothing but probability density. Okay, he is explaining that this is the nucleus, these are the orbitals. Okay, in the orbitals at which region electron density is present. Okay, that region of electron is explained by probability density. Okay, the region, it is denoted by letter called psi square. Okay, where psi square is high, nothing but where the region of finding the electron is high, that is called lobes. Okay, these are the lobes, this is the nodes. At lobes probability density is maximum. Here psi square is maximum, which is nothing but the higher the probability density, that region finding of electron is easily and highly. Okay, here psi square is 0, which is nothing but there is no probability of finding the electron. That region is called node. Probability high region is called lobes. This is also lobe. Okay, probability high region finding of electron is called lobes, but probability is of finding the electron region is 0, which is nothing but the nodes. Remember these two units. Okay, let's go to our favorite equation, nothing but the Schrodinger wave equation. The equation is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi equal to 0. Okay, psi equal to 0. This is the main equation providing for the Schrodinger wave equation. What, madam? What is dou square psi by dou x square, dou square psi by dou y square, dou square psi by dou z square? These are nothing but the Cartesian coefficients. Okay, it is nothing but if the moving of electron is in x direction, y direction and z directions, these all are called Cartesian coefficients. Cartesian coefficients. This equation is explained with respect to Cartesian coefficients or with respect to polar coefficients also. The polar coefficients are nothing but pi, theta and r. Okay, here we are telling with respect to Cartesian coefficients. These are polar coefficients. Okay, but here we are telling with respect to the Cartesian coefficients. Okay, here x, y, z are the Cartesian coefficients. From this, we are mentioning that dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square is nothing but the mathematical constant Laplacian equation. Okay, Laplacian. This is the Laplacian operator. Laplacian operator. By using this Laplacian operator, we are mentioning in the equation, using the Laplacian operator, we can rewrite this equation is del square psi plus 8 pi square m by h square into e minus v into psi equal to 0. Okay, from this, here I am writing del square psi plus 8 pi square m by h square e minus v into psi equal to 0. Okay, we can convert this term outside of the equal. Then del square psi equal to plus term converting this side, you get minus 8 pi square m by h square into e minus v into psi. Okay, e minus v into psi. We can crisscross this equation. Then we can rewrite this equation is del square psi h square by 8 pi square m. Okay, that equal to minus e minus v into psi. Okay, if you multiply psi with these two terms, then we are writing del square psi h square by 8 pi square m equal to minus e psi, minus into minus plus v psi. Okay, from this equation we are converting v psi into this side. Then we are writing del square psi h square by 8 pi square m. This plus term coming to this side, it get negative sign, then v psi. Okay, that equal to minus e psi. Okay, multiplying both sides by using negative sign, then we are writing minus del square psi h square by 8 pi square m minus into minus plus v psi. That equal to minus into minus plus e psi. Okay, from this equation we take psi as a common. Then we are writing minus del square h square by 8 pi square m plus v into psi equal to e psi. Okay, e psi. This term is nothing but h cap. This term is nothing but h cap. Here h cap is a Hamiltonian operator. Hamiltonian operator. Okay, by using h cap we are writing h cap into psi equal to e into psi. This is the major equation of Schrodinger wave equation. By using this equation we can find the radial parts and angular parts of the electrons. Okay, here we are using two mathematical operators which are del square and h square. Okay, here del square is the Laplacian mathematical operator and h is the Hamiltonian mathematical operator. Okay, this is the conclusion for the Schrodinger wave equation. By using this Schrodinger wave equation we can find the density, probability density of the electron by using the Schrodinger wave equation. Okay, this wave equation is used for finding the lobes. How many nodes are present in the atom, which is explained by Schrodinger equation. This is the main equation which leading to the basic for the next coming classes, quantum mechanics. Okay, please make note on the equation. If you have any doubt in the atomic structure classes or any doubt regarding the running classes, please ask me in the comment section. Okay, thank you. Have a nice day.